Welcome to our webinar on how to visualize your data in a web browser with Cesium Ion and FME. This webinar is going to demonstrate how you can use Cesium and FME together to generate 3D visualizations of your data, which anyone can view and interact with in a web browser just by going to. So I'm Tana, Product Marketing Manager at Safe Software, and with me I have Devet, the software developer who worked on adding Cesium Ion support to FME. And joining us remotely is Gabby, software developer at Cesium. The agenda, first Gabby is going to explain what this new Cesium Ion platform is and what it can do. Then I'm going to explain how you can use FME to prepare your data and send it to Cesium. And then Devet and Gabby will give us a demo. And throughout the webinar, keep an eye on the GoToWebinar control panel because Stephanie is going to be chatting out links and additional information. So take it away, Gabby.
Hi. So Cesium began with Cesium.js, which is our open source JavaScript library for 3D web visualization. And that allows people to visualize things on any device. We saw that it was being used across many industries like real estate, air and space, sports and entertainment, engineering. And what people were doing is they were ingesting massive amounts of 3D geospatial data, like BIM and CAD models, City GML, point clouds, photogrammetry, and it was hard to render and stream these efficiently just as is. So we developed a format called 3D tiles, which is an open format, and it allows streaming of this data efficiently, and it's optimized for rendering. So Cesium Ion, what that is data for use in a Cesium.js application. It also allows people to discover other 3D content and control their asset with tokens. So you can then take that data, use it in Cesium.js to render it, style it, perform analysis, and otherwise interact with the data.
Let's jump over then. So what is FME? The gist of it is that as of FME 2019, which you can download today in beta, you can prepare and send your data to Cesium Ion. So FME is a data integration platform that lets you build workflows to pull data from any source and transform it to meet your needs. Cesium is one of many systems that you can write to. FME Workbench, which you can see on the little laptop image there, is where you build your workflow to prepare and convert your data for Cesium. Your workspace is going to involve a few components. First is a reader or readers to extract the source data from wherever it is. And then you'll send the data through a series of transformers. And whatever ones you use depends on what you're trying to do. Devet's going to show us a few useful ones, but FME has a whole library of transformers for enriching and processing data. And if you browse safe.com/transformers, as well as the user-added ones on hub.safe.com, you can see the full extent of them. The key piece of the Cesium puzzle is in a new transformer called the Cesium Ion connector, and this lets you push your data as assets to the Ion platform. So FME does have support for getting data into Cesium in two other ways already, and that's the Cesium 3D tiles writer and the Cesium 3D point cloud writer. And these are format writers, meaning they're the endpoint of an FME workspace that writes your data to a 3D tile set. So this 3D tile set can then be streamed into a Cesium.js app. Basically, once you've converted your data to a 3D tile set with one of these writers, you would then host it somewhere like S3 and build a JavaScript visualization using the Cesium.js library. The Cesium Ion connector, on the other hand, pushes your data to the Cesium Ion platform and generates a Cesium.js visualization. It gives you back a URL to the visualization instead of outputting a file like with the other writers that I just mentioned. So a brief detour, this transformer is the first one to be implemented using packages. And the concept of packages is something new that will launch with FME 2019. The idea is to make more transformers available via FME Hub instead of baked into the product. so that we can easily push new and updated transformers to FME users as they happen. This is also going to make it easier for third parties to create transformers. The infrastructure for this is in place in the betas, so you can look forward to that in the next release. And we'll talk about it in more detail too as FME 2019 launches. So now Devet is going to take us through building a workflow to prepare a data set and push it to Cesium Ion.
Thanks, Tana. Okay, so I just need to
you should
escape here. Okay, and head on over to my machine. Okay, so what we have here, it's a bit of a cooking show format. We've got some stuff already pre-baked here, just to streamline things a bit. But I will be going through the whole process of how to get your data up to Cesium Ion. So we've got we're starting with some flat footprint building footprints, and we're going to extrude them into 3D buildings, and also add some SketchUp models and some imagery, and that's all going to go up to Cesium Ion. And then at the end, we're going to automatically email a link to Gabby, and she's going to take it from there. Okay, so if we take a look at the some of our starting data here, we've got the Canada Place and Convention Center models, and this is the page for the Cesium Ion connector. So these are some of our ingredients. Let's also take a look. Got a link to the building footprints here. So I have taken a subset of the whole City of Vancouver data set, just in the interest of processing time. But this is a publicly available data set that you can go and play with at your leisure. So this is in shapefile format. So I'm going to add a shapefile writer here, or reader here, and paste the data set there. It's in a zip file. I'll be able to read that. And let's just take a quick look at that. Make an inspector here, and I'll zoom in a bit because it's kind of small there. That's a different visualization that was still cached. I'm just going to run this and get the actual footprints. So you can see here, this is just 2D data, just some flat building footprints, but they do have this height attribute that we're going to use to extrude them into 3D. And so these buildings consist of building parts, and each has a unique ID, but then there's also a building ID, so we know which building they're from. And this will become quite useful later. So now I'm going to add an extruder, connect this up to the building footprints, and set the distance to extrude by to the height. Okay. And let's take a quick look at that too. And so there we can see this is defaulted to 3D. And you can see there you have your 3D buildings.
Are these footprints from the City of Vancouver data portal?
Yeah.
Okay.
Yeah, they are. Sorry, let me just quickly kill my Slack client there. Okay. Yeah, okay, so now that we've extruded that data from the City of Vancouver, we can start setting this up for City GML writing, because we want to upload a City GML data set to Cesium Ion. I have already set up some custom transformers here, because we need to create these sort of empty shell buildings, and then put the building part geometry into each part of the document there. So in the building prepare, this is for the empty building shells. We're going to set the level of detail name. It's multi-surface, level of detail 2. They've got unique IDs, they've got a measured height, etc. And remove the geometry because they're just empty shells for the buildings. And then the building parts, we're going to, for this current data set, we're going to just validate and create some attributes. We'll take a look at these later with the SketchUp models. So the validator what this will do is it'll do some basic integrity checks. And if the geometry is valid, it'll pass. But if it fails, we're going to reject it and actually terminate the translation. If it can be repaired, that's also fine, of course. Set up some more attributes in here. Again, level of detail name, level of detail ID. Now, the other interesting thing here is that we set the parent ID, which will refer to the building ID from the data set. And then finally, we have to set the level of detail name as a geometry property just to write it properly into City GML. And we do have some more resources about writing to City GML if you are particularly interested in that.
On knowledge.
On the knowledge,
yeah,
knowledge.safe.com.
I wanted to mention that the geometry validator is a really key transformer here. I think when you're working with any sort of 3D data like this, that has to be robust before you send it to Cesium Ion. It uses some pretty advanced algorithms that our super smart engineers have been working on for years. So yeah, definitely consider that one for all of your Cesium related workspaces.
So what I'm doing here is just setting up these different custom transformers. Now we do need to aggregate by building ID for the building preparer, and this should be only validate only. So we're going to choose building ID here. Okay, and at this point, we're pretty much ready to write the footprints to City GML. So I'm going to add a feature writer. Set this up for City GML writing. And I'm just going to put this in buildings.gml. Okay. We don't need this default feature type, but we can import some because we want sort of a pre-canned schema to write to. So I'm going to choose the City GML writer, no data set, and set this here, the City GML version for importing feature types without data set to City GML 1, and we'll import those. And so there's a lot of different types of city objects here that we can use, but we're mostly interested in building and building part. So I'll add those, and that should be good to go. So we'll connect this up, building preparer to building, and building part validator to building part. And that, of course, should be on the rejected port instead. Okay, great. So we've got the feature writer here. Now, just a minor quirk, which is going to go away actually from the FME side and Cesium Ion side. We just need to replace some backslashes with forward slashes. I'm not going to go into the details of this. It's just a simple text read and write, but this is going to be addressed soon on both sides, I believe.
Is that a platform thing?
It's a platform thing, yeah, because I'm on Windows and then online it's Linux. And,
that just happened to me yesterday. I was like, what's happening? And it was just the slashes were the wrong way.
Exactly. So, but yeah, we will probably default to forward slashes there, and then Cesium will go to accepting backslashes as well. So we won't need to worry about that anymore. Okay, so after we have done that, we just need to get out the folder where we wrote the GML file. I mean, we could just type it in manually, but let's do this in sort of a more robust way. So we only need to change it in one place. I'm adding a file name part extractor, and we're going to look at the data set here, and we're going to get the directory path as the relevant attribute there. And then from there, we're actually ready to upload to Cesium Ion. So I'm going to try and add a Cesium Ion connector. And we see here that it's not listed under the regular FME transformers or custom transformers. It's a hub transformer. And so that means it's not installed yet, but that's not a problem. You can see the documentation here, see what it does, get an idea of it looks like, what we want to use. So I'm just going to add that to the canvas, and you can see it's installing the package.
And this is going to be really good moving forward. That's the intention with hub and packages and stuff, is that transformers are more dynamic and they can be updated on the fly. You don't have to wait for the next FME release to get the latest version.
Yeah, exactly. Because we connect to a lot of different APIs, and if one of them changes, you'll no longer need to wait for a release, for a new FME release if we're shipping it as a package. So the interesting thing with packages is that they don't only contain the transformer, which was already sort of available in Hub as a custom transformer, but they can also contain web connections. So you'll see after you install this package that you can now add a Cesium Ion account. I've got a couple set up here already, but I will add a new one just so you can see the workflow. Oh, that built something odd there. So you can now just right out of the box enter your credentials here. And this isn't kept by FME at all. This is all through Cesium. We just get permission to access these specific parts of Cesium. So listing, reading, and writing assets. So we're going to allow that. And there, now we have this connection. I'm going to use the one we've set up before here, the demo one. And for the source folder, I'm going to use the directory path that we got out earlier. For the name, actually, because I will be uploading some additional data, I'm going to add an attribute creator just to be able to make this more generic. Add an attribute creator here and enter the asset name that I want. Name as an attribute. So we're going to call this Vancouver. The building's not footprints anymore. And just add a timestamp, the date time now function, and that should be good to go. We can set the asset here to be the asset name, and there's also the option to wait for Ion to finish processing, but we don't need to do that in this case because we can send out the asset URL already, even if it's not done processing on the Cesium side. And so the Cesium Ion connector will automatically pick up the format of the data. We do support uploading OBJ files, City GML, LAS files, and GeoTIFF imagery. So those will all be picked up automatically if you point to a folder containing those.
And I think that's an important step in these workspaces too, is that before you upload or before you attempt to upload your assets to Ion, you do need to convert it to one of those 4 formats.
Yeah, exactly, exactly.
And that's where the feature writer is good. That's what you're doing there. You're writing it out to that format and then pointing the Ion connector to that file.
So here we're just going to send out an email to Gabby so that she knows when we've uploaded the assets. I just need to, because we're going to add some more data to the Cesium Ion connector, we just need to aggregate the URLs. So we're going to concatenate. Let's see, here's all the metadata coming back about the asset, the Cesium Ion URL, separated with new line. And then in the emailer, we can, so I'm just going to send this from myself. Data is ready. Say the following assets have been uploaded, and add the Cesium Ion URL there. Use my Gmail account that I have set up already. Okay, so this should be. Here's
a question, and I'd like to know the answer too. So if somebody has files already in like the Cesium 3D tile format, could they send that into the Ion connector? And upload that?
That is not ready to go yet, but we are planning to add that functionality.
Okay. And then one more question. What about, so the Ion connector right now just has the upload option. Are we also considering adding like a download and read option for this?
There's no specific plan for that at the moment, but this will be, this will be, of course, open to new ideas and depending on what, what our users need.
I think right now one of the tiles formats is also a reader. Is it the point cloud one or the other one? One of them is. We can do the tile format, yeah.
Okay, so this is for uploading the imagery. We're just going to create a new feature here and set its asset name. This is going to be imagery, so Vancouver orthophotos. Just do a similar thing there. And the dir path is going to mimic what the file name part extractor gives us. They're in orthos. So we've just got a directory sitting here with a few ortho photos. And so those are georeferenced and that'll be picked up automatically by Cesium. So this part of the workflow is ready to go. We're also going to add some SketchUp models. I'm not going to go into that in quite as much detail, but we will be uploading the workspace and you can take a closer look at what happens there. But so we can get these URLs directly for the for Canada Place and the Convention Center. So I'm going to copy that, add a SketchUp reader, paste the URL. Okay, there's that, and the other one over here, copy that, add another SketchUp reader, paste the URL there, Convention Center. So these will come out as one feature, so we'll eventually need to de-aggregate them instead. This is the processing. So the one model is geolocated and the other one is not. So there's some slightly different steps there. And we'll go through those in just a second. So this is for georeferencing. We're going to set a coordinate system, scale the model, rotate it, and offset it. Connect that up. For the other one, it's in inches, need to reproject it and just scale it a bit. Do that. We're setting up just a synthetic building ID attribute because these need to match up with the footprints data set. And de-aggregators to split these into the individual building parts that we need. Okay. And so this is the whole ones can go into the building preparer. And the parts can go into the parts here. And in the part validator, we are synthesizing some attributes here, the measured height. We're calculating the max minus min there for the height and generating some unique IDs. And then the rest of the process is the same as with the extruded footprints. Okay, so yeah, and this is a bit messy. We'll upload a much cleaner version of this, of course, that you can take a look at. So I think this is ready to run. Oh, just one more thing. The two SketchUp models are already in the footprints, so we need to actually remove them, remove those buildings from the footprints. I've just set up this tester with a listing of the IDs that we need to remove. Okay, so this is ready to run. I'm going to go ahead and do that.
We've had a couple of questions come in.
Sure.
So this one might be for either you or Gabby or both. Will this work for on-premise Ion servers?
This won't upload to a different server at the moment. So I'm not familiar. Is that, can you deploy a Cesium Ion
I'm not
server
sure. Maybe
on
that's a
premises?
Gabby question.
Yeah, that might be a good question for Gabby.
We have on-premise tilers, but we don't have an on-premise Cesium Ion platform.
Yeah, it's in the works.
Okay.
And once that is available, if it works the same way as the publicly available Cesium Ion server, we should be able to modify the Cesium Ion connector to upload to both.
Yeah, same idea. Okay, and then a question wondering if FME is translating in the connector or in the Ion backend. So I guess which parts of the workspace are doing. So yeah, all the pre-processing and translating is happening on your machine in FME, and the Ion part is basically like their tiling pipeline. I think that's kind of where
what we upload to Cesium Ion in this case is a City GML file with associated textures. And then Gabby can talk about this a bit more, but they have a tiling pipeline on that side which converts from City GML into Cesium 3D tiles.
Yeah. Okay, one more. So someone has land XML data, and if that data has height values, can we use this to convert to 3D tiles? So yes, you should be able to extrude that into 3D and convert that.
Probably, yeah. If you have
easily.
2D and height, you can generally get that to
yeah,
3D
people do that all
tiles.
the time with FME. You just give it your height values and it'll extrude that to 3D.
Yeah, but if you have a question about a specific data set, our FME experts are happy to help out with that.
Yeah, we've got live chat on our website. You can just reach out and they can help you out. But yeah.
So yeah, I guess we can go over to Gabby. This translation was successful, and she can show us how to visualize on Cesium Ion.
Awesome, thank you.
So here's the email right in my inbox with the following assets have been uploaded with the links. Click that and it brings up Cesium Ion right here. So the imagery up there is already uploaded and tiled, as you can see over here. There's a preview over here, and we also have the City GML data. That's worker again, sorry. But what we have here, this is your asset page, and this is a list of all the assets that are associated with your account. So we have, I'm going to quickly sort by uploaded date. So we have the assets that have been uploaded via FME, and we can see that the City GML is all finished tiling over here as well. You can see it in the preview window. And then we have some previous attempts that me and DeWitt had experimented with. And then we also have some built-in assets that come with your account. So this includes imagery from Bing Maps, as well as world terrain provided by Cesium. If you go over to the Asset Depot, there is also some additional assets available that you can combine with your assets in a Cesium.js visualization. So I'm going to go back up here. Over to the right in this panel, along with the preview, you can also modify things like the name, the description, the attribution, etc. And for now, what I'm going to do is pull up an example Cesium visualization. So if I come down here to the code window, there's a little snippet of how you could include it in a Cesium app. But I'm just going to right-click and hit open in Cesium Sandcastle. So what this is going to do is this is going to pull up a generated Cesium.js visualization that includes the asset we have there. So this whole application here is called Cesium Sandcastle. And what this is this is a live coding environment. You can see the code over here on the left, as well as the application over here on the right. There's a bunch of examples down here that you can take a look at as well. I encourage you to explore those because it goes into a a lot of the features that Cesium JS has. It's a very powerful library, so if you get the chance to look through all that, you can see what all it can do. So right here, let's take a look at our initial app. What it's doing is creating a Cesium viewer. This is the default Cesium viewer. It's added world terrain automatically, so we don't need to worry about that. So if we pan down, we can see that terrain is loaded in. We also have the default imagery, which is the Bing Maps imagery. And then what we do down here is we add the 3D tile set to the scene. So that's the asset we just created, and then we zoom to it. So we can go from anywhere on Earth down to Vancouver. Did I spell that wrong? Vancouver? Where we have our data. So what we're going to do first is we're going to configure the viewer to be what we want it to be. So I have my code snippets over here because I don't trust myself to type everything out. But first, we're going to configure the viewer to be what we need for this application. So what I have added here is scene 3D only. So what we have, you can, by default, you can come in and you can change the settings in Cesium so they can view it in 2D, or what we call Columbus view, which is like kind of a 2.5D. For this application, we're just going to use 3D, so we'll just disable that button entirely. We also set the selection indicator to false, which just means we're not going to click and inspect the individual building by default. We're going to set that up ourselves. And we're also turning off the base layer picker. The base layer picker is over here. What this allows us to do is choose different imagery. And since we're supplying our own imagery via the orthos that DeWitt uploaded, we don't really need to include that either. So if I hit run, what we should have here is the viewer with those buttons that I talked about removed. Some things you might also see down here is the timeline, which allows you to kind of scrub through time and see like the lighting change and things like that. You can have it play by default, and you can speed up time. So what we're going to do next is we're going to go ahead and get rid of all these tabs, first of all, is upload, or this has already been uploaded, excuse me, include the orthographic imagery that we have here. So in order to do that, what we can do is add the imagery layer. So this is just that this code snippet that we have down here, and I'm just going to paste that right underneath where we set up the viewer. You might notice this line, what this is saying is depth test against terrain. This is just saying that anything that goes underground, just hide it. So that's just a aesthetic choice right there.
We've got a question. Someone wants to know if we can add a transparent ceiling layer, say if you want to classify above or below asset elevation.
I'm sorry, can you repeat that?
If you can add a transparent ceiling layer. Is that?
I'm not sure I follow by transparent ceiling layer.
I don't know. We can follow up with that question because I'm not sure.
So now you can see that we have that orthographic imagery layered over top of Bing. So that's a little bit higher resolution than what Bing normally provides. So if we zoom in, we can see the orthographic on the right and Bing imagery on the left. So since we have all our assets in the scene, what I'm going to do now is I'm going to configure the ion asset token. What assets tokens do is allow you to in a more fine grain specify who can view what assets. So right now the default asset token grants access to all of your assets. And you probably don't want to include that in your app, especially if you have an account that has a lot of different assets in it. So what we want to do is create an access token that just gives access to the assets that we want to include in our app. So I'm going to come over here to asset tokens, and I'm going to add a token. So I'm going to call this Vancouver. So we don't need access to list or write any assets. We just want to read, and we also want to geocode. Geocode is this little search guy up here. So if I type Vancouver, it'll find Vancouver. So we'll allow that as part of this app. And we want to provide it to selected assets. So we're using Bing Maps Aerial as our imagery layer. We're also using, oh darn it, there's a lot of orthos. I'm going to include all of the Canada data that we've have here, each version. So we need Canada Place, orthos, Vancouver buildings, and then finally we're using Cesium World Terrain, so I'll include that as well. So let's hit add, and I'm going to copy this token, and I'm going to paste it right up here. And get to the end of this string. Forgot a quote. So if we run this, it should still just still work, is basically the intention, right, when you run this. Perfect. So the next thing we want to do is kind of start going in and tweaking the actual functionality and the aesthetics of this app. So let's go back to my source code here. One of the things I'm going to do is, as part of terrain, I'm going to request the water mask because we're right here by the bay. So what this will do is request as part of terrain where the water is and add custom effects to that area. I'm also going to turn on lighting, and what this is going to do is basically shade the globe based on where the sun is, so you'll see night and day in a more realistic way. So I'm going to hit run again. So now you can see the water mask has a water effects applied, and then if we pan down, well, everything's still loading in a little bit, but you can see that night and day are actually come into play now. So if I scrub the timeline, you can see the sun rising and setting and the shadows changing.
That's so cool. That's so powerful. I love it. Wow.
All right. We've added our tile set. All right. So the next thing we want to do is interact with these buildings a little bit more. So right now they're just kind of the white extruded geometries. And what we want to do is style them according to different parameters. So some of the attributes that were included with the data set were the height of the buildings as well as the height above terrain. So what we can do is we can apply styling to the 3D tile set in order to show that off. So I'm going to come down here and add this function style by height. And I'll explain a little bit more what that does. So come down here, get rid of that for now. I'll come back to that. So what this does is this just sets the tile set, which is the Cesium 3D tile set that we added earlier. It sets the style to a new style, which is an expression-based language that we can use to basically use certain features to determine certain aspects of the tile set display. So in this case, it's a CSS-like expression to determine color. So I'm using hue, saturation, and lightness to determine the actual color scheme. So I'm using the height attribute. I'm dividing it by a value to scale it accordingly to get a hue, and then I'm just setting the saturation and lightness. So if we actually call this function, you should see this in action over here. So now we have the shorter buildings with lower height colored in red, and the taller buildings colored in blue, and then the in-between buildings shaded accordingly. So that's one way to actually view the content of your data. I'm also going to set an optional other styling for styling by terrain height. And what this is going to do is this is going to grab a different attribute, terrain height. You can see that we're calling the height attribute here, and we're calling terrain height in this one. So if I call this guy instead, it will style those buildings according to the height above terrain, or the terrain in which the actual geometry is placed. So you can see that we have higher elevations up here and lower elevations down here, which is pretty cool. So now we can see graphically that things are changing, but if we want to get the actual values and interact with the individual geometries themselves, we're going to add something that we call picking, which allows you to grab the feature that's under your mouse and basically do things with it. So I'm going to, first of all, I'm going to add a quick drop down that'll let us go between these two functions so we can switch back and forth. These are helper functions that are included with Sandcastle to just add a toolbar. So you can add HTML and CSS just like you would with a normal web app, but I'm just going to call this helper function to add that easily. And I think so since our first item in the dropdown is styling by height, I'm going to set that back to this. And if we run this, I have a little drop down up here so I can switch between the two of them. So there's buildings by height, and there's by terrain height. Cool. So now I'm going to add in picking. So first of all, I'm going to create a variable to save the selected feature, just so we know which one we have selected. It's going to have two properties, the feature, which will save the actual object itself, and then the original color, because I'm going to tint it a little darker color when we have it selected. And we want to be able to set it back when we're done. So this is the function that will actually reset the selected, previous selected object back to its original color. So what I'm just doing is setting the feature color itself. I'll include the actual source code for this in as part. I think we can send stuff out afterwards, right? So you can take a look at this source code yourself and play around with it as well. So what I'm doing here is I'm going to add a screen space event handler, which is something that is watching, in this case, mouse events in the scene. So I'm going to be looking at the mouse move event. And when the mouse moves, I'm going to trigger this function. I'm going to then come in, copy all this, and I'll explain what I'm doing. So first thing I'm going to do is pick a feature that is under my mouse. So when the mouse stops moving, I'm going to call the viewer.scene.pick function on the end mouse movement position. So if I am not over a feature, so say my mouse is over here, I'm just going to reset whatever the previously selected feature was, if any, and then not do anything. We're just going to return. If there is a feature selected, and then if it's not the previously selected feature, we're going to, again, reset that original previously selected feature. And then I'm going to select that feature. So I'm going to save it as the selected feature. I'm going to grab the original color and save it so we can put it back later. And then I'm going to turn the color a little bit darker just so we know which one I actually have selected. So if I run that, assuming I copied and pasted everything, we should be able to see under our mouse which one we have picked. So see over there. Oop, yep, so as we mouse over, we've selected different buildings. So if you can see, that's one big building. That's one building. The next thing we're going to do is display the actual value of either the height or the height above terrain. So what we're going to do is we're going to add, where's my HTML overlay? So I'm going to add an HTML overlay that will just contain the information that's in that building. So I'm going to place that. I'm going to place that over the style by building height function so that I can come in here and add some stuff to it. So what this is going to do is just add a div to an HTML div element to the scene, and I'm going to give it the class name label, and then I previously got some styling that I'll just add here. So this will just display it so it looks nice. And currently we won't see anything because it's hidden. So I actually have to make it so when you mouse over, it'll show the div and put it in the corresponding place on the screen, as well as insert the information into the element. So the first thing I'm going to do is I specified a set label callback function here. Depending on which item we have selected in the dropdown, I'm going to pull different information from the tile set. So if we're styling by building height, I'm going to want to get the height property from the picked feature. So I'm just going to use that get property function there. That'll return the number value. So I'm just going to set the overlay text content to the height. I'm going to fix it to 2 decimal places, and then it's specified in meters, so I'm just going to add the meters for specificity. And I'm going to do something similar when I'm styling by terrain height, except instead of pulling in that height property, I'm going to pull in that terrain height property. And then, so what I need to add to my picking function is when I am no longer over a feature, I'm going to hide that display. And then when I am over a feature and it's a new feature, I am going to show the overlay and call that set label callback function to determine the content of the element. So here I'm just setting it to show, setting it to the specific place where I have my mouse in the scene, and then I'm setting the actual value. So let's run that. And so now when we mouse over different elements in the scene, we'll see the actual value. So we can see the tallest building over here has a height of 192.95 meters, and then down here, down to about 11, or even these little guys on the island have 12 meter, 4 meter, etc. I kind of lost myself. Let's go back to Vancouver. There we go. And we can also do the same terrain height. So now we can see that we're going from a terrain height of about 25 down to -19 on the pier. And then we can also see here that these guys also have the textures on them. These are the SketchUp models that DeWitt uploaded as part of this tile set. So these are the convention center in Canada Place over here. So yeah, so that's just a example of some of the stuff that you can do with Cesium.js. It's a really powerful library, so I would like I said, advise taking a look at some of these examples down here to really see the full scope of what Cesium.js can do. Yeah, so thanks, and I will include this demo code over here as part of the materials, so you can take a look if you need. Yeah.
That's so cool, thank you. Where can people access the API for this?
Oh, sure. So if you go to cesiumjs.org, this is the landing page for Cesium.js. If you go to this little developers tab, we have API documentation over here. So those are all of the classes that are available. We also have some tutorials to get you started. So there's literally a getting started tutorial that'll walk you through setting up the app from scratch. And then there's some topics you might want to dive into, like adding imagery layers, working with terrain, adjusting the camera, 3D models, things like that. Also in Cesium, we have an entity system, so there's some tutorials on that as well.
Excellent. Okay, so let's jump back to our slides here. We'll make ourselves the presenter. And yes, perfect. Okay, thanks so much. So yeah, just a quick note here. The beauty of FME workspaces is that you can build them once and they're repeatable. So you can run your workspace to convert and prepare your data whenever your Cesium visualization needs updating. Or you can set up an event-based workflow using FME Server. So this means you can send all your data to Cesium Ion automatically, say if you want to run it on a daily schedule. Or you can trigger the workspace in response to an event, say anytime an end user has new data to convert. Right now, this type of workflow is done via the FME Server notification service, but look out for new functionality in 2019 called automations. We're super excited about that, and it's going to make it a lot easier to build event-based workflows. So just to sum up then, yeah, you can view and interact with all your 3D data in a web browser using Cesium Ion. You can integrate, prepare, and convert your data for Cesium Ion using FME. We showed you a few helpful transformers, and you can browse safe.com/transformers and FME Hub to see more. And if you use FME Server, you can keep your Cesium web app up to date with event-based workflows. So feel free to, oh yeah, we've got a bunch of resources too. You can check these out. We are publishing a tutorial on the FME Knowledge Center either today or tomorrow as well to guide you through building that workspace. We'll share these slides afterwards, so you can click these links. And feel free to chat your questions to us. If we don't answer them right now, we'll follow up via email. And yeah, thank you so much, everybody, for attending. We really appreciate it. Okay, so yeah, thank you so much, Gabby. Okay, I'm just opening up questions here. So what else we got? Okay, yeah, with the transparent layer, I think people are wondering whether they can add a ground layer that's transparent or some kind of contour layer to their Cesium visualization.
Okay, so like blank imagery, basically. You can remove all of the imagery layers from the globe if you just want to display, for instance, one imagery, one ortho layer that you have, or none at all. So you can just remove them entirely if you want. We also have terrain clipping planes, so you can basically remove part of the globe if you don't want to see it, things like that. You can also just turn off the globe entirely if all you want to see is, for instance, a 3D tile set. That's totally possible.
Okay, good. What else?
Gabby, what's the best way for people to reach you if they have additional questions that we don't get to?
Sure. If it has to do with Cesium in general, the forum is a great place to ask. So that's Google Groups Cesium-dev forum, and there's a link on the cesiumjs.org site to that. And then you can also, you can also contact me at gabby@cesium.com. So GABBY@cesium.com.
Perfect. I will just chat out that email for people.
Okay. Do we have any plans to support Cesium terrain quantized mesh format in FME? I don't think that's come up yet.
Yeah, I'm unsure. I can
yeah.
I can get back.
You should be able to upload DEMS or TIFF in order to create quantized mesh with Cesium ion. So what we'll do is we'll take that, tile it up on Cesium ion into quantized mesh, and then you can use it directly in your application.
Nice. Okay. Are there any limitations on geometries uploaded in Cesium, spheres or cylinders?
No.
No. Okay. I think we've answered most of the questions here. If anyone has questions we didn't get to, or if you think of any afterwards, feel free to enter that in your follow-up survey. And we will be sharing the recording and the slides and the workspaces online, so stay tuned for that in the follow-up email. Yeah, I think that's it. So thank you so much, everyone. Thank you, Gabby. Thank you, Devette. Thank you, Steph.
Sure, thank you.
Have a good day.
Zero.
Bye.